And I'll just copy the attendance register link in again. Okay, so basically today we're continuing with study unit 9, and then next week, Ian, we will do a recap of assignment 3. And maybe by that time you need to nearly focus on assignment 4 as well. So let's see if we need to do something for assignment 4 by that time as well. But yeah, next week we'll do a recap of assignment 3. Okay, so into tonight's session. So basically, again, what we will do tonight is under hypothesis testing, very similar things to what we did in confidence intervals. Um, we will at all times need to look at the questions. We will look to calculate Z values or T values. We will use that in the formulas. So basically, again, this is nearly continuation of study unit 6 and 7. And again, we'll go through some of the theory. We go through some of the formulas and things. Again, you don't need to learn them. You have them. And I'll just then towards the end of the night, we will just go through a few examples again of how to answer the questions. Okay, so basically what we're gonna do, and I think this is, I'll share that tonight on the group as well, a one pager that I've also written the steps down. So we're gonna the whole time nearly look at 5 steps that are possible, and it can be that on each step nearly that is your 5 answers in a question. So the first step is that we're going to identify the, let's just get the, we're going to identify the hypothesis. So we're going to look at the hypothesis statements. We'll get into detail in the rest of the slides, but there's normally a null hypothesis and alternative hypothesis, depending on different textbooks. The alternative can be shown as H1. Sometimes it is shown as HA, just to say it's alternative. So again, there's a few different ways of writing it down. But the first thing will always be that we need to identify hypothesis statements. Then what will happen with that hypothesis statement? So depending on what the signage is, we will see if it is a one tail or a two tail. So if our hypothesis is of a null hypothesis is equal, and let's say equal to 5, that will mean that we are dealing with a two tail, because the sign is equal to. I'll show now another example of why we will do that. If it is bigger, smaller, any of those signs, we're going to work with a one tail. Okay, so that is step 2, is nearly to identify if we're going to work with a one tail or a two tail. Then the third step is going to be that in the question, they will tell you what the level of significance is going to be. So the third step, in the question, they would need to tell you the level of significance. So they will say, oh, it's a 1% or 5% or 10% level of significance, or they can tell you what the confidence interval is. So if I get the significance level of, say, 1%, it will be 0.99, or it will be a 99 confidence interval. So just some of the times they give you the level of significance. Sometimes they will give you the other numbers. So we will just need to make sure when we get to step 3 that we know which one we're going to use. And again, then if we use the 1%, 5%, or 10%, we can use that table that is in your study guide as well. And you will see in all the questions that we go through, I nearly have copied that in some of them automatically. Then the fourth step is nearly, we will now look at the options that they give us, and we will need to make a call to say, well, or I reject the null hypothesis, or I accept the null hypothesis. But they can also say in some of the questions, I accept the alternative hypothesis, or I reject the alternative hypothesis. So in step 4, we will basically calculate that test statistic, and we will then make a decision. Okay, and then in step 5, it is basically, so we will, in step 5, we're going to do the rejections or not. So in step 5, depending on what we are using, we're going to make the decision. So if we've calculated the critical value, or if we're using a p-value, or if we're using confidence interval. But again, we'll get to that when we go through some of the questions. In this chapter, again, you will see that there's two things that we need to focus on. I don't see that I've included, so I need to, I'll make a copy, a note here that I need to include something else. So like in the chapter, what was it, chapter 7, there was one where we looked at standard deviation that is known. Then there was where standard deviation is not known. Okay, so that should be not known, is unknown. There's definitely, I'll also check where that is from a book and let you know, because that is a typing error. So there's one where population standard deviation is known. Sorry, it is not. I've read it wrong. Population standard deviation, other one is sample standard deviation. Okay, so if we don't know the population standard deviation, we will at least know the sample standard deviation, and then we will use the t If we know the standard deviation, we'll use the Z. And the one that is missing here is that we're also going to do proportion. So I will just add the proportion to this, and then I will distribute the slides to everyone again. Okay, so like in chapter 7, we're going to work where we have a population standard deviation known, going to work where the population standard deviation is unknown, and we're going to work with one where we're working with proportions. Okay, so let's go into a bit of a detail. So what I think it's also important just, and again, please don't, this is not to learn and to know off by heart, because I'll share it, you have it available. It is just to, if they ask you any theory questions, that you at least have some of these things that they might ask you available. So they just basically give a bit of background on how what hypothesis testing is, the null hypothesis, the alternative hypothesis. Here, I think the important thing here for me is that you have the one tail, your possible one tails, and there's only one possible two tail that you can work with. Okay, so when the null hypothesis is equal and the alternative is not equal, that's the only time we work with a two tail. Okay, so then we go just a bit more into the detail. You might, as you go through your textbook, they talk about type 1 errors, type 2 errors. They talk about level of significance that we already have spoken about is for alpha. So again, just when sometimes they use the sign, sometimes they use the wording. It's just to prepare you for all those things that can happen. What you will also see, so when we work with this hypothesis testing, and we're going to use the normal distribution tables. When we work out the test statistic, and we'll show the formulas again for that. Say that is going to be the test statistic that we're going to work out. This part that we normally look at as a probability is what we call the p-value. Okay, so it can be that, for instances, they tell you that the p-value is a certain probability. Then you might need to work out what the t-stat will be, but just that is nearly where the p-value comes in. So it's not really a different measurement or anything like that. It is 100% linked to the t-stat that you can work out. And later on, I have one or two slides on that as well, so that you can just see how we use it. Okay, so when we gonna work with this. And remember, I said, okay, so the first thing is going to be we're gonna basically create a hypothesis test. We're gonna get the alpha. We're gonna work out what the Z is. Then we're gonna make a decision if it is I reject or if I do not reject. Okay, so like I showed when I started with chapter 6 nearly, I'm going to use this bell-shaped normal curve a lot again to also show you how we will get to the rejection and not rejected area. So just again, this one is the one is the lower tail. So lower tail is on this side, upper tail is on that side. And if we had the two tails, I don't know where that one is now, but if we had the two tail, it will basically mean that it is on both sides. And the two tail is exactly what we normally did with confidence intervals. We would have had lower confidence, upper confidence. So that values there is what we normally would have worked out to use it in our confidence interval rule. So the two tail basically is very similar to basically using confidence interval. Okay, so I'll share this tonight again with you, but I want to get to some of the examples. So the first one, I showed the Z, how we calculate the Z. This is how we calculate the T. So we will work with that. What's also important again to remember from, I think again it was study unit 7, that with T we're gonna work with the degrees of freedom and those kind of things. So just nearly keep that in the back of your mind. Okay, then the next one I just want to quickly show is when we work with proportion. So when we work with proportion, exactly the same. You will see that we're working with a one tail. So whenever we have the smaller, the bigger, bigger, smaller, we get the one tail. And when we work with the equal and not equal, we get the two tails. So exactly the same with proportions as in the means. So nothing have changes in how we will work it out. Then again from way back, chapter 6 and 7, how we're gonna work it out. We've got the proportion. They will give us what we're gonna test it against. And this was just again the shortcut, but you will remember that formula as well from chapter 7. So population proportion, are we going to work out the t-stat exactly the same? And then all the rules that we will have with the Z statistic will exactly be the same for when we're doing with proportions. So when we, and maybe it's in here again, but I think I probably deleted it. So when we, okay, here it is. So we will make the same rules and assumptions with the one tails, even if it is TZ or proportion. So we will make the same assumptions. So it will just be one of the steps that we will look at. I think that is just important is this one tail that we're going to look at. When we've worked out the t-stat, or we've worked out what the z value is, or we worked out what the z value was for the proportion, the next step in deciding if we're going to reject it or accept it is every time going to follow the same principle. So for me, it's nearly if again we understand how we work that process, we'll easily be able to understand it. And that's what I also want to show you with all the questions that we're gonna go through. So let's start. You will see again, as in the previous chapter that we worked through, again, you can take this as a given. You will again only need to worry about 90, 95, and 99. If we actually included, and I should have actually done that, for significance, that will be 1%, that will be 5%, and that will be 10%. And so again, we can nearly say every time that we see these values and we talk about 1%, 5%, these are the things that we automatically can look at. Okay, so let's look at question 1. So what I want to do is, if we go back to step 1, was to say, okay, let's look at hypothesis. Here's a printing error. That should be H0. So H0, y is equal to 1,000, or alternative is not equal to 1,000. So is it one or two tail? What would you guys say? One or two tail? Equal, not equal? So what we are working with here, equal, not equal, we're working with a two tail. Okay, that should have been 2 and not toe. So we're working with a two tail, so that is correct. But let's get nearly in a pattern. So here we have question 3. Equal, not equal, two tail. Okay, so let's see. Okay, a two tail is appropriate. Okay, that will do now. Okay, that doesn't give us any of that. Okay, so let's quickly see. Okay, so that doesn't have anything in for us. I want to explain that now. Okay, so there's only one or two of them. Okay, so we've identified the first step about the hypothesis. Then the next thing that we can look at is, and sometimes they ask the question, so you have a set with t-stat, the critical value. So let's first look at the critical value. So the critical value you get from what they tell us the level of significance is. So level of significance is 0.01. So that is actually 1%. We know we're working with two-tail. So your critical value is going to be 2.58. And so I want to nearly do that for everyone that we have here. So 0.05% level of significance would have been 5%. We work with a two-tail. Two-tail tells me that the critical value will be 1.96. I don't know if I have it here. So critical value 1.96. Okay, let's look at this one. So here they have it in a question set. When alpha is 10, okay, so we know that is alpha is 10. The critical value is, okay, so we have not determined in this question if it's one or two tail. So let's determine if that one is correct. So a popular weekly magazine asserts that fewer than 40% of households in South Africa have changed their lifestyles because of escalating gas prices. A recent survey of 100 households find that 67 households have. Which one of the following statements is incorrect? Okay, a popular weekly magazine asserts that fewer than 40%. Okay, so that's the alternative. So if that's the alternative, that is definitely not. So that should be bigger or equal to. So this one is already the wrong one. But with that, you can see we're working with a one tail. So if we worked with a 10% significance, one tail would have been 1.28, which is correct. Okay, so just to show you again, using the table, I'm not calculating anything yet. I got to the 1.28. Here they give us a lot of information. We will need to work out critical values in any case. So in a test, again, I don't like this because that is, so this must be smaller or equal to. So maybe they've in this one have made mistakes. In testing the hypothesis, so we see it's a one tail because again with that one it's clear it's a one tail. 5% level of significance, we're gonna then sit with this one. But one tail, the critical value gonna be 1.645. Okay, so whenever we need to start working out the rest, we're gonna use that critical value in any case. So that is nearly, you can see my process of getting the easier things done first. So you've worked out if it's a one tail or two tail. You worked out the critical value. So then let's work out the t-stat. Okay, so the t-stat is basically always how we've done it in chapter 7. it is going to be this formula. And then depending on if we have population standard deviation or sample standard deviation, it will just change a bit between a Z and a T. Okay, so here we can see we're working with population standard deviation. So we work with a Z. So we can say, well, we're saying, or the question is saying that we need to check if this is different from 980. So we will check if there's any significant difference between 980 and 1000. We've got the standard deviation as 200, and we've got the n as 100. So square root of 100 is 10. So above the line is minus 20. Below the line is 20. So just also remember that is your standard error. So we've actually answered that question as well. Your standard error is 20. Your Z is minus 1. Okay, so minus 20 divided by 20 is minus 1. So here we again sit, I'm just getting lots of, so that is 0. Here we have your Z calculated as minus 1. Remember your critical value for this one was 2,58. Okay, two tails, so we on this side is also sitting with minus 2,58. Okay, so your t-stat that you calculated minus 1, t-stat that they're telling us is the answer is minus 0,1, so that t-stat is the one that is wrong. But now let's look at this. So the last option that they tell us is reject the null hypothesis when your p-value is less than alpha equal to 0,01. Okay, so that is what we've calculated as your critical value. What we are testing against is that one. So because that falls into there, we're going to accept your null hypothesis. Okay? We're going to accept your null hypothesis because your minus 1 is not smaller than your minus 2,58. Okay, so let me just do that again because it's part of the other slides that we went through as well as part of the theory. But I just want to show it again. So that's minus 1. That is minus 2,58. That was your test stat that you worked out. This was your critical. Okay, so if your t-stat is, okay, so in this instance, so if it is on the inside of your critical value, you accept your null hypothesis. So if we had it that all was on this side, would have been the same. You would have had your 2.58. You would have had your 1 there, and you would have had that the one that you calculated is on the inside of that, so you would have accepted the null hypothesis. Okay, so what they asked in option 5 is if your p-value is smaller than that. So if your p-value is sitting in this area, which means that your critical value would have set in this area, then you would reject the null hypothesis. So what they're actually asking us is if your critical, if your t-stat was sitting here, then would we reject the null hypothesis? And the answer would have been yes. So if your t-stat was, say, minus 3.15, it sits on the outside of your critical value, and then you will reject your null hypothesis. So again, if we look at the positive side, if my t-stat was here 3.15, it's bigger than your critical value, I would reject the null hypothesis. Okay, so this is the most difficult part of hypothesis testing, is nearly to understand when you need to reject or accept. And then what they will also do is to say, well, reject the null hypothesis is exactly the same as accepting alternative hypothesis. Accepting the null hypothesis is exactly the same as rejecting the alternative. Okay, so also very important, nearly when we look at some of the things that they might ask, just look at the terminology, so that you don't just see, oh, the first option is accept, and you think it is the null hypothesis, and then they actually say the alternative. Okay, so, but there is a few included in here that I will show as well. Okay, so that is nearly the whole process of hypothesis testing that we've done in this one question, is identify if it's one or two tail. For me, then the easiest next one is to identify the critical value, because one does that with your level of significance. Then what they will most likely ask is something around the t-stat, so that you can work that out. And then the follow-up on that will be, then we've got the critical, we've got the t-stat, so do we accept or reject the null hypothesis, alternative hypothesis, or something to do with that hypothesis? Okay, so that is nearly the process that we will follow in most of these types of questions. Okay, let me just quickly stop, take a sip of water, and do you guys have questions? I think this is probably one of those study units that I will do more of again. So when I get your timelines for your next assignment, it might be that I even do another one on this, so that we get to understand the hypothesis testing a bit better, because it is one of your more difficult ones. Okay, cool. So let me go to the question 3. So we have identified already one or two tail. It was unfortunately correct. We identified the critical value. So now they ask us to work out the t-stat, and then these two are linked to one another, because again, if you look at that t-stat, we could have worked out the p-value of that link to it as well. So we will see how that links to the t-stat, and then we need to decide if we reject or not. Okay, so let's first see, we've done the two tails, so let's see if it's a Z or T that we work with. For a sample of 35 from a population, we have a population standard deviation. Okay, cool. So we know it's a Z because the standard deviation is known. So nearly doing what we did in chapter 7, we will need to work out what that Z value is. Okay, so they tell us we want to test where it's 450 against the 458. So we want to know if 458 is really significant different from the value 450. Okay, so that is basically what we are going to test, if there's a significant difference between the two. Standard deviation was 20.5. N was 35. Again, sometimes they tell us N is equal to 35. Sometimes they will use the wording of sample. So sometimes, and what I do a lot is sometimes you miss that because all the others are written in the symbol format except that. So sometimes one look for it and don't realize it's actually up front. Okay, so this I'm going to work out with a Excel quickly that answer. So on the top line, we've got 458 minus 450, which gives us 8. At the bottom, we've got the 20.5 divided by square root of 35. So that answer, and I'm just going to round it off now, is 3,465. My final answer is 8 divided by that is 2,31. Okay, so my T-stat is correct because that is what we've worked out. Okay, so now the next step, we will need to find out what that value is, because we will need that to calculate your p-value. Okay, so to get to that value, we will need to go to our study guide again. Let me just open that up. Hopefully I've got it somewhere close by. Right, I just want to. Okay, so I think it's around chapter 6 or 7. Is this the study guide or is this something different? Okay, something different. Quickly check if it's in the 1510 study guide. Okay, 1510 study guide. So I was looking for Z 2.31, Z 2.31. There I have it. 0.9896. So this part is 0.9896. So if I need to work out the small part, remember we say 1 minus, so 1 minus 0.9896, and that gives us 0.0104. Okay, which is that number. But tell me, is that the p-value or not? So if this was a one tail, that would have been the p-value. Remember, this is two tail. So on this side, there's a 2.31 with the same area of 0.0104. So when we deal with a two tail, this small p-value we need to multiply by 2. Okay, so we will need to multiply that by 2 because on this side there's a p-value, but on the right hand side there's a p-value, but on the left hand side as well. So we will need to multiply by 2 when we're working with a two tail. Okay, so this is the catch in this question is they're giving us the right value, but they're giving it to us as if we were calculating a one tail. Okay, so when we deal with a two-tail, whatever the value is, the probability, we will need to multiply it by 2. Okay, so that would have been the mistake in this one. Then the last option is about the null hypothesis. So let's put in, there's the critical value, 1,96. So if we on this side, did I say in that one? Why did I say? Oh, wait. Let me just say, check what I said. So if we're on this side, we actually reject. I now confuse myself in this one. Okay, there's my PC freezing. Oh man. What happened now? Okay. Okay, so let me. So we have that your critical value, your test statistics. So remember what we said here. If your T stat is bigger than your critical, so let's see. If your T stat is bigger than your critical, we'll reject. If it was to the left of that, we will accept. So to that side, reject. To the inside, accept. So at the null hypothesis, we reject at that level. So if it was to the inside, we would have accepted. It is to the outside of it, so we reject the null hypothesis. So here again, they could have said the alternative is accepted. So just again, the other one that could have played here was the alternative is accepted. Okay, but even before we got to that, the one that was wrong was how to calculate the p-value. Again, remember, when it's two-tail, you need to multiply the p-value by 2. Okay, what they also like to ask you, and this will definitely be in one of your assignment questions, is they'll give you a statement and then they will ask you, but what's the null hypothesis and what's the alternative hypothesis? Okay, the first thing to remember is you will only work with this mean. This is the only one that you're going to work with. So whenever they throw in any other symbol, you can eliminate it. Okay, so also if they do something weird, like they say, want to say standard deviation, because that can also be something like that, no go. The only thing that we test is the mean. So please, all other things, or what we call it mean. So that is what we test with hypothesis testing. Okay, so when we then look at the question, Professor of Stats refuses the claim that the average student spends 3 hours studying for exam. Okay, so again, if it is, then because I spoke about it, now I do it. So it's or you spend 3 hours or you don't. Okay, there wasn't in this saying that students are spending more, students are spending less. So what he just says, well, he doesn't believe students are spending 3 hours. Okay, so if it's 3 hours or not 3 hours. And again, now suddenly you see the null hypothesis as that your null hypothesis is always linked to that one. So if I look at these, that might have been your 2, not the others. And then if we add the alternative hypothesis, okay, sorry, that should have been 3. We see that that is your correct one. And again, because that is just smaller than, it's the incorrect. Okay, so they like to ask this. Hopefully they ask it in the exam as well, but definitely in your assignments, you will get something like this in the assignment. Okay, next one. I just want to put on the light. I'll be back in a minute. Okay, so the next one, we're looking at proportions. So follow exactly the same process as we did in the previous, but let's first look at what the answers or what we're looking for, because this looks weird. So they want us to calculate the p-value of a t-stat for this proportion. They tell us that the t-stat okay, so they tell us there's your test statistic is going to be tested with a z equal to 0.05. So that's 5%. Alternative tells us bigger than. Bigger than is only looking at one way, one tail. So again, just following some of the other things. So the t-stat would be that. But we still need to work out what the z value is to get to the p-value. So I'm just going to put in the values and not going to rewrite the formula. They need to give you the proportion that we're going to test against, like they need to give you in the previous ones the x. Now they need to give you the proportion. So they tell us we're testing against 0.63. Again, this one I am going to put in Excel to work out. I don't have my calculator with me at the moment. N is 100. Okay, so and I will split it a bit. So 0.63 minus 0.6 is 0.03. At least the value is positive. Below the line, we've got square root of, so let me first do 0.6 times 0.4 divided by 100 is 0.0024. We still need to take the square root of that. That is equal to 0.3 divided by 0.04, and I'm rounding off, 49. So if I divide those two together, we get a value of 0.61. Okay, so I'm going to test where my Z is equal to 0.61. Interesting, 0.61 wasn't one of these options, but we're basically going to test so that we know again is 0.61. So we want that value there, and that is going to be our p-value. Okay, it's one tail, so we don't need to multiply by 2. If it was two tail, if that was not equal to, we would have multiplied by 2, but because it's one tail, whatever the answer is will be the one that we're working with. So 0.61, 0.61. Okay, so that is 0.7257, 7257. So why don't I get any of these? 7257. So then my answer would be 1 minus this, and I would get 0.38. So let's just see where I have gone wrong here. Okay, so 0.63 is right. 0.6 is right. So then 0.6 and n is 100. I just want to see what have I done wrong here. So that is 0.03. 0.6, 0.4. Let me just make 100% sure why that is. Okay, I will need to check this one because that divided by that is 0.61. I looked at 0.61. Okay, there's definitely a mistake on this one. I will go and check what went wrong here, but this is, so it is 0.3. That is correct. 0.3 divided by that is 0.61. Yeah, so I will need to go and check where this went wrong. So because, let me quickly check. Yeah. So that was nearly the answer. So I just need to go and check what went wrong here, because there's definitely something not right. I'll basically do a recap of this question next time, just to see where it went wrong, because that is definitely not right. The process is right, everything else is right. I don't see that was that, so don't worry. I was just writing error. So in this calc, obviously something is not matching with the answers. So I'll just redo this and get back to you. But the same, and it might be that I even have a wrong set of answers with this, because not even one of them is making sense. Did you guys follow this and got the same answer up until here? I just want to. It's weird that it is so wrong and not. Yeah, I need to check. It's maybe different answer set that is with this, because this is definitely totally wrong. Okay, so we still have time. Let's go to the next one. I'll sort out that previous one. Okay, so as you guys would have seen, so again, we looked at the hypothesis. This one we already identified as being one tail. Then we need to look at the critical value, because that's the easier one to then do. One tail critical value of 10% is for 1.28. So the next thing to look at, let's work out the Z value. But let's first see if it is what we know about this. Okay, so Popular Weekly magazine asserts that fewer than 40%. So we are going to use this formula again. So let's hope it's going to work for this one. Okay, so for this one, okay, we've got Z. They tell us that we test it against 67. So 67 divided by 100 is going to give us 0.67. Okay, this is a massive difference, so there will be a significant difference, but let's just, so 0.4, 0.6. Okay, so that nearly is the same as we did in the previous one. Just the top part is different. So we've got 0.67 minus 0.4 at the top, which gives us 0.27. At the bottom, we've got the 0.4 times 0.6, which will again, like in the previous question, give us 0.049 at the bottom. But then if we calculate that, it gives us 5.51. Okay, so the t-stat is correct. So definitely with this one, there was some error in the set of options. Okay, so like we did with the previous question set, okay, we've got the Z value, we've got our critical value. So now you will see they ask us the p-value is equal to 0.0000. So if you look at this, so you can nearly see here for extreme values. Now this is actually a nice one added to the 1510. So you can see for extreme values what your probability is going to be. So here we have 5.61, which was very close to that, 5.51. So if my probability is that, the p-value will be 0.00000001. Okay, so that is why this looks weird, but physically we can't round it off only when we get to the 7th decimal. So when you start getting to anything above 3.4, we are actually moving into a place where your p-value will be so small, it is 0. So, and what they will normally do is not to say the p-value is equal to 0, it will be 0.0000 with a point. So because somewhere in that process there's probably a 1, because it is so small. Okay, so that is also correct. So let's look at rejection or not. So critical was there 1.28. There is your t-stat. So anything above that, remember, we reject. HO is not rejected. Okay, so that one is the incorrect one. So remember, everything above is rejected. So that is why this one again will be rejected. So what I've done here, and this is just, I added this slide for you guys. So I said when it's bigger, we reject the null hypothesis. So here's ways that you can also look at it. So when your t-stat is bit bigger than your critical value, we're going to reject the null hypothesis, or we're going to accept the alternative. When your t-stat that you work out is smaller than your critical, we accept the null hypothesis, or we reject the alternative hypothesis. Okay, so I just thought I wanted to add a slide like this in for you so that you have it. So this is what I nearly tried to explain way at the beginning, and probably should have waited a bit to explain it now. But this is nearly the important part, that again, now you have it, so you don't need to prove it or anything. You can, when you see your the t-stat that you're working out is bigger than your critical value, you can say, well, thanks, I reject it because that is a rule. If it's the other way around, cool, I can accept it because it is a rule. Okay. Just want to, you can see I tried to explain it with another example. So when we were, let's look at this question. So again, here they, to reject H0, not to reject H0, to reject H1, to reject H1 is the same as to say accept alternative. So now you can see there's to reject H0 is to say the same as accept null hypothesis. Not to reject null, not to reject is also accept. Okay, so there we're already sitting with two that are the same. To accept null hypothesis because p-value is a minimum. Okay, so that one is not because that's not the reason why we will accept it or not. So this is quite interesting. Not to reject null hypothesis means I accept it. To reject the null hypothesis is, sorry, I accept the alternative. To reject, sorry, that one, see, I've made myself now. So to reject the alternative is actually to accept the alternative. Okay, so then basically, because you can't have two that are the same, that would be my answer. But let's work it out. So we've got the Z value, the critical value. So we need to see what is your t-stat. So from a t-stat, let's get, where is that other formula? Going to use that again. Okay, so we've got 0, what do I say? 0.45 minus 0.4. It will tell us to see. Okay, so they did not tell us the n. So they did not tell us what that n value is. So that is sometimes why we will then say not, I need more information, but we know if they give us that p-value, that is going to be the p-value. It's going to be 0, is it 0.764? So that p-value, we actually can get a z. So remember 0.0764. So if I again go to the tables, I want to know this bigger area. So that is going to be 0.92, what's it, 36. 9236, 9236, 9236. There we have it. 9236 is 1.43. Okay, so we could actually work out that as 1.43. So this now takes you back to study unit 6 and 7, where we did probabilities, how to get to certain of the Z values and things like that. So now we can look at this again. We have the t-stats as 1.43. We have your critical as 1.645. So if your t-stat is to this side, we accept. So that's why we accept the null hypothesis. So that is just what I, again, wanted to show here is there is your critical to that side of that we are accepting it. So your test value was smaller than your critical, so we accept it. So again, this is just a bigger way of showing how we got to that. Okay, and that is the end of study unit 9. But I think what we will do is next week we'll do a recap of your assignment 3. Then I think we need to, before we start with study unit 10, even if it is next week or then the week after, just do a recap of hypothesis testing as well. Just to nearly want to go through an example like this again, so that we do all the steps that's needed, just to show again how we get to that final answer if we need to accept or reject something. So that I just want to work through one more, that we just follow all the steps, because I think it was a lot tonight. So it's nearly go and look at the study unit again. Then next week we'll do a recap of assignment 3, and then the week after we will just kick off with study unit 9 again and just do 1 or 2 of it. Just if there's any students that's new tonight, please send me a WhatsApp on 0837908387. I'll add you to our WhatsApp group. Yeah, and I'll also post the YouTube link onto the group as well. Cool. Any questions, anyone? I know, yeah, this was study unit 9 is really one of the more difficult study units. Study unit 10 is also not too easy because it also have hypothesis testing and those kind of things in. So study unit 9 and 10 are the two most difficult study units of this subject. So again, don't be too worried yet if some of it didn't make sense. We've got way enough time to make sure that you get this. I think compared to last year, we're nearly a month ahead on where we need to be. So we've got enough time to practice and practice and practice for your exams. Okay, cool.
Thanks for that.
Cool. Yeah. So don't worry yet. I think that's why I want to share the video tonight as well, that you guys can go and look at it again, and then just for next time we'll do a recap. Okay. Cool, everyone. Have a good evening. I am going to stop the recording so that I can put it onto our WhatsApp group.